Hi, I'm Carlie Markey. These are my teammates, Ben Howell and Nguyen and Nayan Patel, and this is our project, Highway to the Danger Zone. So this year for the Big Data Cup, there was a specific focus on analyzing power plays and penalty kills. The direction we took this in was trying to understand what causes a power play to be successful. And to do that, you need to understand that a successful power play is largely defined by being able to create or take advantage of defensive breakdowns so that the team can generate offense. And then, vice versa for a penalty kill. And in light of this, our goal with our project was to first build a model that could tell you what these dangerous situations are in a data-driven way, and then put that model into usable form, not only for analysts, but for coaches, the actual end users of the actual conclusions and takeaways of this model. Spoiler, we did do it. And here's the URL in case you wanted to play around with our web tool during our presentation for yourself. So this journey to making this web tool was pretty complex. So let's start with how we handled this year's data.
Yeah, so we use clean versions by @thebucketlist on Twitter of both the play-by-play and tracking data provided for this year's Big Data Cup. And since we're focusing on dangerous situations from the perspective of the power play, we filtered out any events sort of non-essential to that specific aim. So events that the penalty kill was responsible for, events in the defensive zone from the power play's perspective, and things like face-off and penalties that aren't directly involved the power play and the penalty kill, sort of phasing off trying to get the puck. So after we did this, we ended up with 820 what we called game states, which are just the play-by-play events with all the event details, as well as the player locations gotten from the tracking data. So from there, using that data, we started to build out our model.
So for there, we wanted to define what a dangerous situation looked like in our model as we use that as our independent variable. To do this, we manually hand-tracked 13 of the women's hockey games from the 2022 Olympics this year, and found that on average, we saw roughly 3 unbroken passes happening before a high danger unblocked shot, which is, an unblocked shot from the home plate area. That's kind of common in hockey analytics. So going off of that, we decided to say, okay, any high danger unblocked shot or any pass that occurred within 3 unbroken, an unbroken chain of 3 passes before, those 4 events collectively would count as, dangerous situations in our model.
Yeah, and so one of the most important parts of this project ends up being the minimum spanning tree framework that we use to connect and define player relationships on the ice. And so what a minimum spanning tree is essentially a method of connecting points along the shortest possible path, and doing that using obviously the distance between the players on the ice as what we're defining as the path. And this allows us to pull variables out of the minimum spanning tree and turn those into variables that we use actually in our model, rather than just using raw XY coordinates of player positions. A couple of those variables are listed on the slide, but if you want to see the entire list, go read our paper. And so as to how we actually use the model to treat those variables, next slide. Yeah, we ended up using a logistic regression model and taking those 10 base variables that we had and turning them into more variables to using the polynomial features function sklearn, pairing that further down using the select k-best for variable selection to make sure we weren't overfitting our model, as well as using a lasso-based logistic regression to account for all those variables.
Yeah, so we wanted to provide an interactive way to explore the predictions of the model, so we created this web tool. It's primarily built using D3.js and uses the Interact.js library for dragging. So a user can drag around nodes representing the player and the puck, and as they drag, they'll see the changes in the probability of a dangerous situation predicted by the model. So we wanted to give you a little taste of this web tool in action, so we pulled an example from this most recent Stanley Cup final.
Yeah, so I think where our web tool is most powerful is taking our model and using it in a practical way where we can combine our web tool along with traditional video analysis, where we can go frame by frame and see how dangerous situation probabilities change up or down. So here's an example, as Ann said, from game 2 of the Stanley Cup final. Right here we have a classic 1-3-1 power play that Colorado set up in, with Nathan MacKinnon having the puck on the near side. The danger situation currently in this frame is about 35%, according to our model, as kind of a baseline. As we move on, he drives the puck to the middle, ends up peeling away. And as you can see kind of in our model, this actually is rated as, almost a 65% probability of being a dangerous situation. And I think this clip kind of highlights, one of the drawbacks possibly of our model, where, with the relatively small data set we worked with, the further refining it to just power play events, we really it leads to misleading or non-intuitive probabilities that sometimes come up like this, especially given the fact that, we don't include things like movement or speed or direction in this, which is something that is highlighted here, where, the idea behind this play, according to the model, would be to try and pass it to the middle or down to the blowing point, where, the defenders in this clip are doing a good job of keeping their sticks in the passing lanes, which is why there's discrepancies there. So as he pulls back, takes it back up to the point to try and create space, bring the penalty killers kind of closer to the point. We're back to our dangerous situation probability baseline of roughly 35%. And what he does here is he passes to Cale Makar, and they kind of rotate, as all good power plays do, where they switch positions, trying to cause the penalty killers to get out of position. And we see our dangerous situation probably tick up a bit, almost 40% now. And as you can see here, he passes back to MacKinnon with speed, as he's able to, in the last few frames of that clip, driving in. And I think, our dangerous situation probability is actually shown to be a little low here. What I think it doesn't account for is the speed that MacKinnon's coming in with, as well as Makar, kind of drifting back into that empty space that you'll see he'll exploit just here in a few seconds. And then, MacKinnon finds Rantanen on the far side for the kind of key pass of this dangerous situation. As you can see in our model, it explodes the probability up to above 60%. And that, the key thing that happens here is that you can see Killorn on the top right of the penalty killers kind of gets caught flat-footed, and that's reflected in our model. And then that kind of leads to the outcome, which is a goal from Makar as he passes across the wide open slot, and you can see our dangerous situation probability now at 80%. So that's kind of just a quick example of how you can combine the two, video and our web tool.
So one of my favorite things about this project is that every single person we show it to has a new idea on how to use this tool. And I'm sure everyone watching at home has already come up with their own usage for it. However, as analysts, we do see 3 explicitly interesting avenues to pursue to further investigate how power plays and penalty kills work fundamentally. First, would be doing an automatic evaluation of different passing options in the power play formations, and then predicting the most optimal pass, and then integrating that in the web tool in the future. The second is doing an automatic search of the local area around players and optimizing, doing a local search around players to optimize defender or attacker positioning. And then third, would be more of a systems application as a whole, kind of just doing what we did with the video review and breaking down the game states frame by frame to really dig into the causes of defensive breakdowns or successful attacks as we're going forward, and as these are some future uses of our tool. So in conclusion, we developed the highway model and the highway to the danger zone web tool. Again, the URL is there if you want to play with it yourself. It has some immediate applications in player tactics, systems, tactics and systems analysis and development that we've already seen it used in the public sphere by people like Jack Hahn and others on Twitter, doing breakdowns of power plays and penalty kills. And finally, in building this tool, we really believe that we started down a road of understanding of how power plays and penalty kills work as a whole. And if you guys have any questions, we're happy to answer them at this time.